Tomorrow we're going to do the rest of this standard, which says derive the formula for the area of a sector. The first thing we need to know is what is a sector. And a sector is part of a circle. It looks kind of like a piece of pie that you're used to. All right, so if we want to find the area of a sector, we want to know how much space it takes to fill this whole part of this circle. This right here is a really cool website that you can go and see how, as the piece of pie changes sizes, how that affects the area. If you want to go check that out, that would be something cool to do. Again, here's our formula sheet that we're going to be able to use. We can use this for right triangles. We use this when we're talking about circumference of circles or the distance around the circle. But today we're going to be talking about area, so we need to use the area formulas. And we're going to be worried about areas of circles, and that's our area formula for a circle. So it's always good to know where you can go on the formula sheet. So since we're using area of circles, this is the part of the formula sheet we're going to use, which says area equals pi r squared. So if I want to work on the first example here, I would say that the area equals pi times 7 squared, which would be pi times 7, which would be 49 pi. Again, that's the exact answer. If you wanted to find the estimated answer, you would put 49 shift pi in your calculator and hit the SD button, and it tells you it's 153.938, so that would round to be 153.94. So you've got your exact answer and your estimated answer. The second example is a little bit different because instead of knowing the radius, we know that the diameter is 20 feet. So in order to use this formula, we need to know the radius. So if the diameter is 10 feet, then how far would it be from the center to the circle? To do that, you have to divide by 2. So that would give me my radius is 10. And again, I would use my formula. Area equals pi r squared, so 10 squared. If I substitute in the 10 for r, if I square 10, that tells me my area is 100 pi. And again, that is my exact answer. If I want to know the estimated answer, I would multiply 100 times shift pi, and that would give me 314.159. So I would say 314.16 because the 5 needs to round up since the 9 is bigger. Here I want to, if I know that the area of the circle is 236 square inches, I want to find the radius. So I'm going to use my area formula, but this time I'm going to substitute my value in for area since I know that the area is 236. And I want to find the radius, so I'm going to say pi times r squared. So what I have to do is I have to isolate the r. So in order to isolate the r, the first thing I'm going to do is divide both sides by pi. So I get my calculator and I put 236 in the numerator and I put shift pi in my denominator, and it tells me that that's 75.121, and that equals r squared because here the pi's cancel. So in order to solve for r, I need to isolate the r and I need to get rid of the squared. So to undo squaring a number, I have to do the opposite, so I'm going to take the square root. So I'm going to press the square root button, and I'm going to say 75.121, the square root of 75.121, and it tells me that r is going to equal 8.667, so 8.67 if I round up. My second example tells me that the area of the circle is 857 square inches. It wants me to find the diameter. So I'm still going to use my area formula, but I'm going to substitute 857 in for A, for area, and that equals pi r squared. So again, I need to isolate my r, so I'm going to divide both sides by pi. So I get my calculator out and I press 857 divided by shift pi, and that tells me that r squared is 272.79. That equals r squared. So in order to solve for r, I've got to get rid of the square, and to undo a square, I've got to take the square root. So I take the square root of both sides. So I'm going to press square root 272.79, and that tells me that r is going to equal 16.52 if I round up. But the problem is I don't want to find r, I want to find the diameter. So if the radius of a circle equals 16.52, how would you find the diameter? Well, I know that a radius goes from the center to the edge, and the diameter goes all the way through. So what I would need to do to find the diameter is multiply 2 times 16.52, because it takes 2 radii to make a diameter. So my answer is going to be 33.03. Make sure you answer what the question's looking for. Now, what we want to do is apply that, because now we don't want to find the area of the whole circle. We only want to find the area of the shaded part, the area of this sector, which is part of a circle. So you're still going to use your area formula for the circle, which in this case would be area equals pi times 8 squared, which would be 64 pi, because 8 times 8 is 64. Now again, I wouldn't go to an estimated answer. I would leave 64 pi. That is the area of the entire circle. The sector is just part of the circle, and the part of the circle that we're looking at is 60 degrees out of a total of 360 degrees. Remember, fractions represent parts. So I want to know that 60 degrees out of 360, and I know the area of that entire circle is 64 pi. So in order to get the area of the sector, I'm going to multiply. I'm going to hit the fraction button, 60 over 360. And I'm going to multiply that times 64 pi. So 64 shift pi. And that tells me my exact answer is 32 over 3 pi. Now if I want to get an estimated answer, all I do is hit the SD button. So I know that equals 33.51. Estimated answer, exact answer. Here's a different one. It looks harder because it's got a fraction. All right. Again, we want to know the area of the sector, the shaded region, which is this part here. So in order to do that, I need to find the area of the entire circle, which would be area equals pi times r squared. Now, I don't like putting 4.5 in my calculator, and I know half is the same thing as 0.5, so I would say 4.5 squared. So if I put that in my calculator, shift pi times 4.5 squared, that tells me that the area equals 81 over 4 pi. That's the entire circle, but I only want the shaded part. So what's shaded? 120 degrees out of a total 360 degrees times the total area, which is 81.4, or 81 over 4 pi. So to get my answer, I use the fraction button. I use 120 over 360 times 81 over 4 shift pi. And that tells me that my exact answer is 27 over 4 pi. If I want to know the estimated answer, all I've got to do is press pi, SD. So that gives me 21.21 if I round up. So that gives me the estimated. That gives me the exact. Now, here we've got an example where they give us the area of the sector, and they want us to find the radius. All right. Now, one problem here is that 161 is not the degrees of the shaded region. If I wanted to find the degrees of the shaded region, I would have to subtract from 360. So 360 minus 161, that would give me 199 degrees. So that's the part of the circle that we're looking at. If I know that the area of this shaded region is 84.14, the way that I get that is that that's the part of the circle, 199 over 360 times pi r squared. Let me fix that. So I'm going to say 84.14 equals 199 over 360 times pi r squared. That's how I would get 84.14 if I needed to. So in order to solve for r, I need to isolate the r. So I'm going to divide both sides by 199 over 360. They cancel on the right-hand side. I get my calculator and I say 84.14 in my numerator. In my denominator, I have a fraction, 199 over 360. So that tells me it's 152.21 equals pi r squared. Now again, they want me to find the radius, so I need to solve for r. So to solve for r, I need to divide both sides by pi. So I get my calculator and I say 152.21 divided by shift pi. And that tells me it's 48.44, which rounds up to 45. And that equals r squared. I still need to solve for r. To get rid of the square, I need to do the opposite of squaring, which would be taking the square root. So the last thing I need to do is take the square root of 48.45. So r equals 6.96. So that would be my radius. So I know r, that's what I wanted to find. I'm through. On this one, they want me to find the diameter. Again, they give me the angle in the unshaded region is 109. If I want to find the angle in the shaded region, I need to subtract that from 360 because there's a total of 360 degrees in a circle. So the angle over here is 251. So if I know the area of this shaded region is 72.39, the way I would find that if I needed to would be 251 over 360, because that's the part of the circle I'm concerned with, times pi r squared. So in order to solve for that, I need to isolate the r. So I'm going to divide both sides by 251 over 360. They cancel on the right. So when I put it in my calculator, I would say fraction 72.39 over fraction 251 over 360. And that would tell me 103.82 or 83, I need to round up, equals pi r squared. And that's my area formula. But I don't want to know the area, I want to know the diameter. So to know the diameter, I've got to keep solving. So I'm going to solve for r. To solve for r, I divide both sides by pi. So I get my calculator out. I say 103.83 in my numerator. Shift pi in my denominator. So that tells me that I got 33.05. And that equals r squared, which is still not what I want to find. So to keep solving for r, I got to get rid of the square, so I take the square root. So I hit square root on my calculator, 33.05. So that tells me that I get 5.75 for r. But that's still not what I want to look for. I want the diameter. But so if the radius equals 5.75, then the radius would have to be twice that, because it takes 2 radii to make a diameter. So I would say 2 times 5.75, and that's going to give me my denominator, or my diameter. So 2 times 5.75. So that tells me that the diameter is 11.5. So now I've answered that question. All right, we'll be working some more on these. Just remember that you use the area formula to find the area of a sector. All right, and then the sector is only part of the circle, so you have to multiply the area times the part of the circle that you're concerned with.